The question is 500 ml of 2.2 molar aqueous solution of acetic acid is mixed with 5 ml of 0.2 molar HCl at 25 degrees Celsius. So we need to calculate first the degree of dissociation of acetic acid in the resulting solution and pH of the solution, and the B part is if 6 gram of NaOH is added to the above solution, determine the final pH. Ka for acetic acid is given, which is 2 into 10 raised to the power minus 5. So let's get started. We have moles for acetic acid equals to M1V1. So our volume is half liter into concentration is 0.2 molar, which is equal to 0.1 mole. Our moles for HCl will be equal to volume into concentration, which is 0.1 mole. Now, since our HCl is a strong acid, so we can say that H plus will be mostly due to HCl only, because HCl is very strong acid as compared to acetic acid. So we can say moles of H plus will be equal to moles of HCl, because one molecule of HCl will provide one ion of H plus, so it will be equal to 0.1. Also, volume of solution will be equal to 500 plus 500 ml, because we have 500 ml of acetic acid solution and 500 ml of HCl solution, so it will be equal to 1 liter. So our concentration of H plus ion in the solution will be equal to 0.1 divided by 1, which is equal to 0.1 molar, and hence our pH of the solution will be equal to minus log base 10 H plus concentration, which is equal to 1. So this will be the pH of the solution. Now, considering the equilibrium for the dissociation of acetic acid like this, here we have initially concentration of acetic acid is C0. Here we have none, and here we have none. At equilibrium, we will be having concentration as 1 minus alpha, C0 alpha, and here as we have added the H plus, as we have added the HCl, so our concentration will be equal to 0.1 plus C0 alpha, with 0.1 coming from the HCl basically. Okay, so this will be the total concentration of the H plus ion in the solution. So we have Ka equal to this. Our Ka is basically 2 into 10 raised to the power minus 5. Our concentration of acetate ion is C0 alpha. Our concentration of H plus ion is 0.1 plus C0 alpha, and our concentration of acetic acid is C0 1 minus alpha. Since our alpha term is very small, so we can write it as 2 into 10 raised to the power minus 5 equals to C0 alpha into 0.1 divided by C0 1 minus alpha, because our alpha is very small, so this will cancel out, and our this term is also equal to 1 basically. So our alpha will turn out to be 2 into 10 raised to the power minus 4. which is the degree of dissociation of the acetic acid in the presence of HCl. Now let us come over the B part of the question. The B part is saying that when we add 6 gram of the NaOH in the solution, then what will be the final pH of the solution? So we can say moles of NaOH in the solution will be equal to 6 divided by 40, which is equal to 0.15. So firstly, our NaOH will react with the HCl. So the reaction will be NaOH plus HCl giving NaCl plus water. Our moles for HCl is 0.1, we have calculated above. So remaining moles of NaOH will be equal to total moles minus moles reactive with HCl, which is equal to 0.05 moles. Okay. Now the remaining moles of NaOH will react with acetic acid. Okay, like this. CH3COOH plus NaOH giving CH3COONA plus water. We have moles for acetic acid equals to 0.1. Okay, so our moles for sodium acetate will be equal to 0.05, which is equal to the moles for NaOH that is reacted, and hence moles of acetic acid which is unreacted will be equal to 0.05, and hence our solution will contain these two, basically the weak salt and its corresponding a weak acid and its corresponding salt of with strong base, basically. So it will form buffer solution. So the pH of the buffer solution will be given by pKa plus log base salt, which is sodium acetate, upon acid, which is CH3COOH. Since the moles for salt and acid are same, so we can write pH is equal to pKa, which is minus log base 10, 2 into 10 raised to the power minus 5 plus log base 1, because our moles for sodium acetate and acetic acid are same, which is equal to 0.05, and volume is also same, which is 1 liter. Okay, so on solving, our pH comes out to be 5 minus log base 10 2 is approximately equal to 4.7. So this is the pH of the resulting solution. I hope that I made myself clear. Thanks for watching. Have a nice day.
In this question, it is telling that the average concentration of SO2 in the atmosphere over a city on a certain day is 10 ppm. Okay, that is parts per million. When the average temperature is 298 Kelvin. And it is given that the solubility of SO2 in water, that is 1.3653 mole per liter. Okay, and the pKa value of H2SO3 is 1.92. We have to estimate the pH of rain on that day. Okay. So, what is given in the question? That is the concentration of SO2, that is 10 parts per million. So, when we convert into mole per liter, we multiply by 10 to the power minus 6. So, that is 10 to the power minus 5 mole per liter. Okay. And the solubility of SO2 is given, that is 1.3653 mole per liter. Clear? And also the pKa value is given, that is for H2SO3 as 1.92. Okay, so the SO2 present in the atmosphere will get saturated with the water molecules, okay, that is coming in the form of rain. So what will happen? SO2 will react with water and it will be giving H2SO3. Okay, so clearly we can see stoichiometric ratio of SO2 and HSO3 is 1. So we can say that concentration of SO2 will be equal to concentration of H2SO3, and that will be equals to the solubility, that is 1.3653 molarity. Okay. Now further H2SO3 will give 2H plus and SO3 2 minus ions. So let initially the concentration of H2SO3 be C. Okay. Then let the dissociation be A by 2. Then how much will be left? C minus A by 2, and this will be A and this will be A by 2, right? So we can write for this K value or Ka will be equals to product of concentration of the product, right? That is H plus whole square multiplied by SO3 2 minus divided by concentration of the reactant, that is H2SO3. So in the question we have pKa value. So from that Ka value will be 10 to the power minus 1.92. So let us substitute here all the values now. 10 to the power minus 1.92 is equals to H plus concentration is A, so it will be A square multiplied by SO3 2 minus is A by 2 divided by H2SO3 is C minus A by 2. As A value is very less compared to C, so we can neglect A by 2. Okay, so it becomes A cube by 2C equals to 10 to the power minus 1.92. Okay, this implies A cube by 2 into C. C is the concentration, that is how much given in the question, that is 1.3653 is equals to 10 to the power minus 1.92. Okay, the value of 10 to the power minus 1.92 comes out to be 0.0120. Okay, so this implies A cube is equals to 0.0120 multiplied by 2 multiplied by 1.3653. So this implies A will be the cube root of 0.0120 multiplied by 2 multiplied by 1.3653. Okay, so that is the cube root of 0.03276. Okay, so it comes out to be 0.320. Okay, so here the value of A we got as 0.320. It is nothing but the concentration of hydrogen. So H plus ion concentration is equals to 0.320. So we have to find the pH in the question. So easily we can find it now. pH equal to minus log of H plus, that is minus log of 0.320. So it comes out to be 0.49. So this is our answer.